All right, we are trying a different one, a different recording thing, so hopefully this works. What we're doing for this one is we're looking at how to calculate plus or minus, really we're going to work on standard error, plus or minus 2 standard errors. So I've already got, we're looking at boy heights, and so 72 is 6 feet, so this would be 5'7", 5'9", 5'11", 6 feet, 6'2", 6'6", pretty tall one there. Girls, 5'3", 5'7", 5'5", 5'1", 5'8", and 5'10". And so we took means, and I'm not going through standard deviation. I'm going to go through it really quickly, but I'm not going to talk about each step because that was in another video that we did. So the mean for the boys was 72. We subtracted that, squared it, and got these values, added them up. And so when calculating standard deviation, that goes on top, divided by n minus 1. N is 6. It's how many boys we were looking at. So there were 6 there, so n minus 1 is 5. 75 divided by 5 is 15, and the square root of 15 is 387. Okay, to find standard error, we then take that value, that 387, and we divide it by the square root of n, which was 6. So 387 divided by the, 3.87 divided by the square root of 6 is 1.58. which we are just going to round on up to 2 just to make things easier when we graph. Now when we are graphing, we're going to be going up 2 and down 2 standard errors. And the reason we're doing 2, if you'll remember from your reading in your e-packet number 1, I think it was in all those places, your chapter 1 through 3 readings in the live notebook, plus and minus 2 standard errors or standard deviations is going to be 95% confident. And so that's what we have to be confident in order for our values to be valid. So that means if we're going up 2 standard errors, and one standard error is 2, so 2 standard errors would be 4, then we're going to go up 4 and down 4. Okay, so that's for the boys. Our mean is 72. Our standard error bars are going to go up 4 to 76 and down 4 to 68. All right, for the girls, same thing. Calculated the mean, it was 66, subtracted the mean from each value, squared it, added those up, got 56. Plug that in over n minus 1. We had 6 girls again, so there are 5 girls. That was 11.2 square root, so our standard deviation is 3.35. All right, 3.35 divided by the square root of 6 is 1.37. And we're just going to round that, again, for simplicity's sake, to 1. If one standard error is 1, then 2 standard errors is going to be 2. So we're going to go up 2 and down 2. So our mean is 66. We're going to go up to 68 and down to 64 on our graph. Okay? So I've already created the graph for you just to save time. You notice I've got my axes labeled, got my units, got even spacing, I've got a title, all the things graphs are supposed to have. My boys are graphed at 72. I've already added my standard error bars, so I went up 4 to 76, down 4 to 68. And I know that my true mean is somewhere in that range. What I mean by that, with standard error, when you look at your sample size, let's say this is 17-year-olds. Okay, so we had 6 17-year-old boys, 6 17-year-old girls, but we know that there's a lot more 17-year-olds in the state, in the country, in the world, whatever we're looking at. And so in order to extrapolate out to that, we can use standard error. So we know that the mean for our sample, for this sample, was 72. But by extrapolating out, by calculating standard error and creating these standard error bars, we can say with 95% confidence that if we looked at every 17-year-old in South Carolina, or every 17-year-old in the country, or every 17-year-old in the world, boy, they would fall, the actual mean, when we calculated the mean for everybody, would fall in this range. Okay, so that's what that means. All right, for the girls, we had 66. We're going to go up 2 to 68, down 2 to 64. Okay, sometimes it's good to write those values on there. It helps to trigger your memory there. So 76 and 68. And so what we're looking at now is the girls. We know that the mean for this sample size was 66. But if we extrapolate it out to the entire state, country, world, or whatever, we know that with 95% confidence, the actual mean would fall in this range. Do these ranges overlap? Well, this one could go all the way down to 68 and all the way up to 76. This one could go all the way down to 64 and all the way up to 68. So yes, it's potentially possible that the boys could be at 68 and the girls could be at 68, which means they could have the exact same mean. That tells us that there is no significant or statistically significant difference, and we would need to accept our null, that there is no statistically significant difference in the height of boys versus girls. If, however, they had not overlapped, let's say this one went down to 69 and this one only went up to 68, so there was no overlap, then we could say with 95% confidence we would reject our null and say that there is a significant difference. So that is how you calculate standard error, plus or minus 2 standard error. That's how you add those bars, and that is also how you use that to then accept or reject your null. I hope that helps.